Hi everyone, welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. So everybody let me know in the chat box if I'm clearly visible and audible to all of you or not. So everybody in the chat box, am I clearly visible and audible to you? Yes, students. So today we are going to do conductance, insulators, like basic of that. Then we are going to discuss about what is conductivity, what is molar conductivity, what is the relation with resistivity and resistance, right? Then we are also going to see that for strong and weak electrolyte, how you can find all of these, right? And there is a law based on that, that is that is what I say, Kohlrausch Law. Okay, so something weird name it is, right? So you can pronounce it the way that you want, right? We can say it's Kohli law. Okay. Yes, everybody. So shall we start with the session? And I can see very few students are here, right? But let us also see how many of you have done yesterday's homework. Okay, so let me see. Yesterday that we talked about Nernst equation. None of you have done the homework. Guys, what is this? I mean, you guys don't do your homework, right? That's really bad. That's really bad that you guys are not doing homework, right? So, shall I solve this? No. Ma'am will not solve this. Yeah? Your choice. You don't want to do the homework, right? Then why will I solve it for you? Huh? I have provided you the DPBs also of solution chapter of some basic concepts of chemistry, and I'm very sure that you guys have not even looked at it, isn't it? So why you are doing this to yourself? Huh? You need to practice it, right? I am here to tell you the concept. After that, you need to practice it yourself. Only then things will actually turn into something good, right? So that's why again I'm saying, because very less time you had yesterday night, only we had our class. So that's why I'm giving you more time to do homework, right? This is the homework for your previous session, right? In the previous class, you have to write down the answer for this one, okay? Right? So let us start. Actually, I should delete this, right? Okay. I know you guys got the hint, but let's see who will try to solve it themselves, right? So talking about conductance, conductivity, molar conductivity, equivalent conductivity, firstly you need to understand what exactly is conductors, okay, and what are insulators, right? So conductors are which help, not help, which allows the electricity to pass through them, right? For example, we have silver. All the metals are conductors. We have gold, we have copper, steel, sea water, NaCl. Why sea water is a conductor? Because simple water, we add NaCl into it. See, simple NaCl is not a conductor. But aqueous solution of NaCl is just an example, that is sea water, ocean water that is having salt in it, that is a good conductor of electricity, right? So these are some of the conductors in our daily life, and these are the insulators, right? So which do not allow electricity to pass through them. Like you have rubber, glass, oil, diamond, dry wood. These are the insulators that we have. They will not allow electricity to pass through them. Now, if you remember, right, there is a non-metal which is also a very good conductor, right? Any idea on that non-metal? That non-metal is carbon, okay? So that non-metal is carbon, which is a non-metal, and in terms of when it is used up as graphite, when it is that is the allotrope of carbon, right? Because of the free electrons, right? Because graphite has hexagonal shapes, right? These kind of shapes it is having, right? So one carbon atom is attached to three atoms, right? So one electron is free here, and that free electron is conducting the electricity here. Because of those electron movement, there is electricity here. right? So, you know what that I am saying, I'm specifying that this is electron movement, right? Now, based on what kind of current, what is making this current to flow, right? That will define two types of conductors that you have. First conductor is metallic conductor. Second is electrolytic conductor. Metallic conductor is the one through which the current is flowing through with the help of electrons. Electrons are moving and that's why current is flowing, right? Second is when we talk about electrolytic conductors, through that in an electrolyte the ions are flowing and that is making the current to flow. So we can say over here ions are flowing. Okay, so two types of conductors that we have that pass through current here. First is with the help of electrons, second is with the help of ions, right? Now if you see that these metallic conductors, electricity is conducted by electron, and electrolytic conductors, electricity is conducted by ions, right? Now let's talk about the difference here. Difference is very important for you, right? So first is metallic conductor carries electrons, right? See, in metallic conductors, what exactly happens? For example, you have a metal, okay? So in that metal, you will have atoms, right? These are called kernels, okay? These are called kernels, right? So these will be your atoms. So here what you will have is free electrons, right? That will make the electricity to flow. And in electrolytic conductors, what you will have here is you will have electrolytes, you will have some reactions going on here. And because of ions in this solution, it will the current will flow here, right? Okay, so that the reason is ions. So now metallic conductor, the first difference is that metallic conductor carries movement of electrons and electrolytic conductors carry movement of ions. There is movement of ions here. Second is no change in chemical behavior of conductor, right? Because no chemical reaction is happening here, right? In metallic conductors, there is no chemical reaction inside the metal that is happening. See, for example, through the copper wire, current is flowing, right? In your home, it is happening, right? In all the houses, this is happening, right? Now, is there some chemical reaction in the copper? No, there is no chemical reaction as such. Electrons are flowing there, right? So that's why there is no chemical reaction here. So no change in the chemical properties. But here, there will be chemical reaction that will result in the formation of electricity, right? Okay, that is the reason we are saying it involves decomposition of the electrolytes as a result of chemical reaction. Because of the chemical reaction, this is happening. Now, electrolytic or electrolytic cells, we are going to talk about that in the next lecture in detail. So, this particular point will be more clear to you that what are these chemical reactions, how the current is actually there because of this, right? Third is, it does not involve transfer of matter, only electron. Electron has 9.1 into 10 raised power minus 31. This is a mass of electron, which is very less. So that's why we are saying there is no travel of mass, right? There is no transfer of mass here. But in case of electrolytic, there is transfer of ions. That means ions are gaseous ions. There can be helium positive or whatever are the ions. Now these ions have some protons, they have some neutrons. That's why they will have mass, right? So that's why there is transfer of matter here. There is transfer of mass here. Okay. Yes, students. Next is metallic conductors decreases with increase. Now this is a very, very important point. This is extremely important point, okay? Very important point. If you talk about metallic conduction decreases with increase in temperature. So it says that when you increase the temperature, here metallic conduction will decrease, but here electrolytic conduction will increase. Now, ma'am, why so? Let's see this, okay? In metallic conductors, when you increase the temperature, what will happen? It will start vibrating. these atoms will start vibrating, right? Now you can think about it that in a room there are, let's say, 20 students sitting, right? Suddenly there is a news that there is fire in the building, right? So what everyone, but the room is locked, what everyone will do? They will start like getting very anxious that what is going to happen now, this and that. So they will start colliding with each other, right? When they will start colliding with each other, it will make them even tougher. This is what happens now when there is too much crowd, right? And suddenly some news is there that there is earthquake or there is fire in the building, some kind of news is there. What happens exactly? People start colliding with each other, and that is the reason the electron find it very difficult to flow, because these atoms are vibrating. Now this electron is not getting any direction to flow. This makes it difficult for the electron to flow. That's why conductivity decreases. That is the reason here conductivity will decrease. Now in this case, what will happen? There is a solution, right? You are increasing the temperature. Now there is no atom as such, like they are like kernels standing next to each other vibrating. There is no such thing. In the solution you have ions, right? When the temperature will increase, kinetic energy will increase for ions, right? And that's where their movement will increase, and that is the reason conductivity will increase. Okay, or you can say conductance will increase. Is that clear, students? Right, everybody? Is that clear or not? Till now we have discussed about conductivity, conductance. Do let me know if that is clear or not. Do let me know, guys, if that is clear or not, everybody in the chat box, right? Okay, yes. Now next is what you have, electrolytic conductance. Okay, in electrolytic conductance, basically we have two kind of electrolytes, right? Now let's discuss about strong electrolyte and weak electrolyte. Okay, so when you discuss that what is strong electrolyte, okay, in strong electrolyte, for example, you have HCl. Let's take an example, or let's say NaCl. Okay, this is a strong electrolyte. Why? Because we know that dissociation will definitely happen, right? But in case of strong electrolytes, if you have 100 molecules, I am just taking a random example. If you have 100 molecules of NaCl, you will have 100% dissociation. 100 molecules of Na positive will be formed and 100 molecules of Cl negative will be formed. So all the molecules that you have will be dissociated in the end. That is a strong electrolyte, and that's why we say alpha is 100% here, or we also take in fraction alpha is taken as 1. Okay, that is strong electrolyte. Now what are strong electrolytes? Strong acids, strong bases, salts, all these are strong electrolytes. Okay, more discussion will be there for strong electrolytes, weak electrolytes in ionic equilibrium, right? Next is the factors affecting it, right? Wait a minute. Yes, let me just teach you weak electrolytes. Wait, I forgot that where is this weak electrolyte slide, okay? So weak electrolyte is which do not dissociate to 100%. Let's take an example of CH3COH, right? Now here, what you have is, I'm taking assumption that you have 100 molecules, okay? Out of this, let's say it is 50% dissociated, okay? Now dissociation will be this thing, right? If I am saying that it's 50% dissociated, that means out of these 100 molecules, you have only 50 molecules are dissociated into these two, plus you have 50 molecules of CH3COH as it is. That is, as it is in the end. These 50 molecules are as it is in the end. So this is called 50% dissociation, weak electrolyte. Let's say it is dissociating to 70%. Then these two things, how it will change? That means 70 molecules are getting dissociated out of 100 and 30 molecules are as it is intact. So this is the case of 70% dissociation. Okay, right? So when dissociation is not 100%, right? It can be 90, it can be 80, it can be 70, 60, 50, 30, 40, 20, 10, whatever, right? Now, if the dissociation is not 100%, all the molecules are not getting dissociated, that is called a weak electrolyte. Now, weak acids, weak bases, all these are, let's say this is a very weak acid, this is a weak base. So these are acting as weak electrolytes. Okay? Yes, everybody? Now, next point is to discuss that what are the factors that is affecting this. Right, everyone? Let's discuss the factors that is affecting this. Right? Let's discuss it. So the factors that is affecting this is, if you talk about solute, okay, two solutes. If the interaction, you can think about this, when two people, right, you and your best friend, you are talking to each other in the class, right, your conductivity will be very low. Why? Because you are so busy in talking to each other, you are so busy in interacting with each other. Ma'am is saying answer this, answer that, answer this, you are not even looking at ma'am, right? You're just so busy in that, right? So when solute and solute interactions are very high, they will be so attracted, interacted, whatever you say with each other, that they will not move only. They are just talking to each other, that's it, right? Solute-solute interaction increases, conductivity will decrease. If solvent-solvent interaction increases, similarly, if solvent and solvent are interacting with each other, let's say you have a solvent molecule, right, that is very much like have a very strong attraction with the other solvent molecule, right? Now, again, the motion of the ions will be very low, right? Because the attraction is high, that's why the movement will be low, that's why conductivity is going to be low. So that means if you talk about interactions, when solute-solute, solvent-solvent interactions are more, then the conductivity is going to decrease, right? Okay. And even if you talk about solute-solvent interactions are low, even then conductivity is going to decrease, right? Now, this is the same thing that if solvent-solute interactions, what will happen? Let's talk about this thing, okay? Let's talk about, this is a very, very important thing, right? Based on this, I'll tell you that how questions are asked. See, I'll just show you here. This kind of question is being asked, okay? So, ionic mobility of this under electric field, this is how they ask you the question. You have to identify which has maximum conductivity or ionic mobility, okay? And this is the kind of question that they have asked in JEE 2025 exam. So high chances are that they will ask you this in NEET 2026, right? So it's a very, that kind of topic that usually students skip. Most ignored topic that, okay, what's the need of doing this, ma'am? Such an easy question they will not ask. But the concept behind this is very important, okay? So let's understand that. The concept says that, students, here you have solute and solvent are interacting with each other, right? Now, let's say this is your solute, okay? This is the solute. Out of this, you have one atom of solute. This is solvent, right? What will happen in the solvation process? That atom will be crowded by the solvent molecule. This is the solute that will be crowded by the solvent molecule. Okay. Now understand this thing, that what exactly will happen here. Okay, I'm just going to write it here. If you talk about size of the ion, let's talk about, because we want to know that which will have high conductivity or low conductivity. If you talk about size of atom, right? See, less is the size of atom, more number of water molecules can be surrounded. Okay, more is the size, less water molecule can be surrounded. Okay, so that you should know that. See, you can take an example from a daily life, that if you talk about someone who is very innocent, okay, someone who is very innocent, someone who is very clever, right? So someone who is very innocent, everyone around them will try to have a hold of them, that you don't know, you're doing NEET preparation, nothing will happen here, you will never become a doctor. They are always demotivating you because you have such a low self-esteem, you have such a low confidence. So when your confidence is very low, people are going to stress you. Okay, everyone is going to stress you, right? Make you doubt yourself, right? But when you have very high confidence that yes, I am preparing, I have trust within myself, now when the people will try to, right, put you down, will they have any effect on you? No, right? So when the size is big, right, very few molecules of water will be able to surround it. Okay, so if size of the atom is small, what I can say about it, guys, what I can say about it, if the size of the atom, if the size of the atom is small, then size of the hydrated ion, or you can just say ion, okay, size of ion is inversely proportional to size of hydrated ion. Size of hydrated ion. Hydrated ion. Because see, if lithium, if I talk about, if I compare with lithium and sodium, size of, we know that down the group size increases. So ion means size of sodium is larger than lithium. But hydrated ion of lithium will be greater than sodium, because to lithium more water molecules can surround it, right? Now tell me about the mobility. Tell me just this simple thing. If someone who is very heavy, okay, someone has a lot of mass, they are very heavy, and you ask them to run in a race, right? Because they have to carry their own weight, so they will find it very difficult to run. Mobility is going to slow, right? Similar thing happens here. If the size is more, size of hydrated ion is more, then the ionic mobility will be less. Ionic mobility will be less. Now you can say this ionic mobility, or you can even say this is conductivity or conductance, whatever you talk, right? So ionic mobility is going to be directly proportional to the size of the ion. Less is the size of the ion, more will be the size of the hydrated ion, less will be the movement here. Based on this particular concept, they ask you the questions in the exam. This is a very important relation. Okay. There used to be times when from electrochemistry, they used to only ask questions from Nernst equation, but now the time is not like that, okay? So around 4 questions you can expect from electrochemistry. Yes, definitely 1 question or 2 questions will be from Nernst equation, but other questions can be like this. Other questions can be like conductance, conductivity. So these topics are also very important for you, right? Now, let's talk about Gother-Doppler mechanism. So what is Gother-Doppler mechanism? It is the opposite of the thing that we just discussed. See, I told you less is the size of ion, less will be the ionic mobility. They are directly proportional. That means H positive ion is very small. H positive ion is very small. So ionic mobility should be very less, because they are directly proportional, right? But this does not happen. This does not happen. In reality, size of this H positive is very small, but its ionic mobility is the highest. So even out of H positive and OH negative, H positive has highest, then we have OH negative. So this is against the rule that we just discussed. That's where it is a proper mechanism, that is Grother-Doppler mechanism. This question also they can ask you, which of the following has highest ionic mobility, right? Those students who don't know that this is the exception, they will directly ignore H positive because ma'am, it is the smallest size. Yes, it is the smallest size, but the exception is even because it is the smallest size, even then it has the highest ionic mobility. Okay, yes, everybody. Now, let's talk about this. We will not talk about now, right? This I will not talk about now. This will talk about once we have discussed about conductance, conductivity, molar conductivity. Then, just by one take, we will discuss that how on dilution, conductance, conductivity, and molar conductivity is affected, right? Okay, because based on that also, they ask you statement-based questions that on dilution, conductivity increases, molar conductivity increases, which of the following is true? These kind of questions are also asked to you, right? So now let us see if you can answer this question here or not, right? Okay. Okay, guys. So let me just see this. Wait a minute. Okay. So tell me one thing, which of the following is correct, right? Ionic mobility of which of the following alkali metal ions is lowest? Now they are asking you the lowest ionic mobility. If you remember, I told you direct relation is the size of ion is directly proportional to which thing? It is directly proportional to ionic mobility. Ionic mobility. Now, guys, if you see this, size of the ion is minimum in which of the following? So, from periodic classification, this is group number 1, that is lithium, sodium, potassium, rubidium, cesium, francium, that you don't have to know. Now, down the group, we know that size increases. That's why ionic mobility will also increase down the group. Okay, so that means this will have the lowest ionic mobility. Answer is going to be A is the correct answer here, right? Okay, answer is going to be A is the correct answer here. Now, let's talk about resistance, resistivity, conductance, conductivity here. Okay, guys. Yes, everybody who are actually learning here, you can let me know in the chat box if that is clear to you or not, right? Otherwise, people like Bhuvna are there to talk, to disrespect your ma'am, right? If you're not speaking, it says that if you're not speaking for right, you are speaking for wrong. So, guys, if you actually think that ma'am is teaching good, right? You are able to understand that, then I'm not asking you to fight with these losers. All I'm asking you is that you can at least respond to me, right? So if you feel that whatever Bhuvna is saying is correct, then it's totally your choice. You don't need to respond, right? That's totally fine. Okay? Yes. Chalo. I'll just put Bhuvna's comment on the Telegram channel, right? On my own Telegram channel. Let me see what these students have to say, right? Chalo. Now, let's talk about this here. That is, what is resistance, what is conductance, okay? So resistance means uh, electron are moving or ions are moving. If someone is causing restrictions in the flow of that, for example, you want to go out, right? But your parents are resisting it. That means they don't want you to go out, right? So when you want to stop the flow of the current, that is the resistance, okay? So electrical resistance is represented by the symbol capital R, and it is measured in ohms. This you must have heard in physics also, right? And in terms of SI base unit, it is equals to kilogram meter square. That you don't have to know. Now, tell me what is resistance and resistivity. Let's talk about specific resistance. Specific resistance is denoted by this rho. This snake-like thing is, this is rho. That represents the resistivity. Okay. Now, resistivity, if you talk about, that is actually the relation between resistance and resistivity is R is equals to rho L by A. That is the relation. But you will say, ma'am, what exactly is the difference? What is this resistance? Like in reality, if you talk about, ma'am, okay, this is the symbol, this is the formula, but what is the difference? Both are symbolizes the that how the flow of the current is slow, right? Both are telling the same thing. Now see this. If you talk about resistance, right, you have, let's say, what should I draw? So I'll draw myself, right? Let's say you have a cylinder here, okay? Now, in this cylinder, right, this is the length, okay? This will define the area of cross section, right? And if you talk about in overall this length and this area, in overall length and area, what amount is the resistance? What is the restriction in the flow of the current? In overall this thing, in overall length and area, that is called resistance. But if I see in this unit volume, what is unit volume? What is unit volume? Unit volume means if I am saying that in 1 centimeter cube, right? That means in 1 milliliter. In 1 centimeter cube or in 1 milliliter, what exactly is the difference here, right? So what exactly is the resistance in this particular volume? That defines the resistivity. That means I am specifying the resistance for just 1 centimeter cube. That means 1 centimeter length, 1 centimeter breadth, 1 centimeter height. For that specific volume here, what is going to be the resistance? That defines the specific resistance or resistivity represented by rho. And when you talk about this overall cylinder, that is called resistance. So resistivity is nothing but it is resistance only, but for just 1 milliliter of the volume. Okay, for 1 unit volume, what is the resistance? That defines the resistivity. Resistance for 1 milliliter of volume, right, or 1 centimeter cube, or 1 centimeter, 1 centimeter, 1 centimeter, that means length, breadth and height, or you can say unit volume. So if you see this or this or this or this, these means the same thing only, right? That defines the resistance for 1 milliliter. Okay. Now let's talk about what exactly is conductance. So guys, conductance is nothing but this is opposite of resistance, right? Resistance means to stop, to resist the flow of current. Conductance means how much current is flowing, right? So resistance and conductance are opposite of each other. Resistance is defined by R, right? And conductance in most of the books is defined by G, or sometimes in some books it is also defined by capital C. But in the formulas here, I will only talk about capital G. Okay. So either you can represent it by capital G or capital C, totally your choice. Right? Okay. So now here it is represented by S, but let's not represent it by S. Right? Let's represent it by capital G. Okay. So let's represent it by capital G. Right? So that defines the resistance. That defines the conductance. Now, if you see the unit of resistance per ohm, so the unit of conductance is going to be per ohm. Okay, that is also called as Simon. So it is also defined as capital S. That is the unit of the conductance. Wait a minute. Achha, they are talking about unit here. My bad, they are talking about unit here, right? Yes, the unit is Siemens, that is definitely represented by capital S, right? But if you talk about conductance, that is represented by capital G or capital C, that is opposite of the resistance. Now let's talk about what is conductivity or specific conductance. That is represented by kappa. Okay, that is represented by kappa. That is a Greek word. Now kappa means capital K, or basically small k, right? So this kappa is nothing but that is opposite of the resistivity, right? Kappa is opposite of the resistivity. Now, if you see this here, if you try to find out what is the unit of resistivity, that will come out to be rho is equals to Ra by L. Resistance is nothing but ohm. So we'll write it ohm. This is, let's say, meter square. This is meter. They will cancel out. This will be ohm meter. That is going to be the unit of conductance. That is going to be the unit of resistivity. That is ohm meter, right? So I told you that this is going to be opposite. So here it is going to be ohm meter. That is per ohm meter. That is per ohm is nothing but Simon. So this is per ohm per meter. So this is going to be Simon per meter. Okay. So here it is going to be, also you can write it as Simon per centimeter. Now that depends. Usually in chemistry, things are like, beaker is small, centimeter only units will take, right? It will not be like meter, 1 meter or 3 meter, 20 meter. These kind of beakers we don't talk about in chemistry, right? Okay. At a very large scale, yes. In a small scale, no. So that's why we usually you will see centimeter inverse only, right? Okay. Because in physics, yes, we talk about large cylinders, right? But in chemistry, we talk about small beakers, right? That's why in chemistry, you will see Simon per centimeter, these kind of things, right? Okay. Now, if you talk about what is the difference, can you tell me, students, what is the difference here? Anybody in the chat box? What is the difference, right? So this is your beaker number 1, right? And let's have one more beaker. This is beaker number 2, right? Let's wait a minute. Okay. Let's have one more beaker here. That is beaker number 3. We don't, it's not allowing me to have more, right? Okay. So let's talk about this. Wait a minute. Something has happened to this board, which I have no idea, right? Okay. So wait a minute. Yes. Now let's talk about this. What exactly is happening here? Okay. Now to understand the core concept of molar conductivity, how on dilution these things changes, you need to understand what exactly is conductance and conductivity, right? If you talk about conductance, in conductance we are talking about that in this particular volume, right? The volume I am changing, let's say I change the volume to this or this, right? According to the volume, right? Are my ions changing, right? Let's say I am not talking about any dilution. I have not done any dilution till. Let's say I am fixing the volume to this much. Okay. Now I want to see that whether in this particular volume, what are the number of ions, right? Or what is the conductance? What is the flow of ions here in this particular length and this particular volume? So if I discuss about in volume V, the conductance is capital G, right? But if I define that, I am only talking about which thing? This is 1 unit volume and I am only going to talk about 1 unit volume. Okay? This is 1 unit volume, right? And I'm only going to talk about this. In this 1 unit volume, if I define that in 1 milliliter of volume, conductance is kappa. That is specific conductivity. So that means when we talk about, we specify that I am talking about 1 milliliter, right? Out of this, for 1 milliliter, you need to define what is the conductance within this volume. That is called as specific conductance or kappa. So here we are discussing about kappa, and here in overall we are discussing about conductance. Okay, this is conductance, this is specific conductance or conductivity. Right, everybody? Right? Now, let's talk about, this is kind of important for you, right? When to understand that, let's say this is sodium, copper, silver, gold. What you need to understand here is that if you talk about, if it is more than 10 raised to power 1, 3, 3, 3, 3, 3, 10 raised to power 1, 10 raised to power 2, 10 raised to power 3, 4, 5, 6, 7, 8, 9, 10, whatever it is, these are going to behave as conductors. See, in JEE, they have asked one question regarding this. So in NEET, till now they have not asked, but in 2026, they can ask you a question regarding that out of this, which of the following are conductors, right? So if it is 10 raised to power 2, 10 raised to power 3, then it is going to be conductor. If it is 10 raised to power minus 16, 10 raised to power minus 18, that is the value of conductivity, then that is going to be a insulator. Okay, that is the way how to understand which will behave as a conductor and which will behave as an insulator. Right? Now, these are another examples based on conductivity. Right? Now, let's talk about this question here that says that the conductivity of centimolar solution of KCl at 25 degrees Celsius is this much. Conductivity, can you tell me what is given here? Conductivity means kappa is given. The resistance of the cell containing the solution is this much. Resistance is given. The value of cell constant. Now you will ask me, ma'am, what exactly is this cell constant? Let's understand what is this cell constant. See guys, cell constant is very, very, very simple, right? Cell constant is nothing but this is G star. And what is the formula of cell constant? Cell constant is nothing but it is L by A, right? Length by area, that is called the cell constant. And the direct formula with conductance, with resistance is going to be G into G star is equals to kappa. This is conductance, this is resistance. You can also write it as G star divided by resistance is equals to 1 by rho. This is cell constant, right, with resistance and resistivity. These are the formulas that you should remember, and these are the direct questions that you have in NEET 2023, right? So let's talk about this. Here you have G into G star is equals to kappa. So if I say that kappa is given to me, resistance is given to me, so can I just write it as G into G star is equals to kappa. So I can say G star divided by R is equals to kappa, because conductance is nothing but that is opposite of resistance, right? So can I say they are asking you G star, that means that is going to be kappa into resistance, right? Now you have to look for the units. This is centimeter inverse. So kappa is in per ohm centimeter. This is in ohm. Ohm, per ohm will cancel. The answer will be in centimeter inverse only. This is 0.021. This is 60. Okay. So answer will be 0.021 or 201. 0.021. Okay. 0.021 into 60. This is going to be the answer for G star, that is cell constant. Okay. After equating this, you will have your answer, that is 1.26 is going to be the correct answer here. Okay. Yes, everybody. Shall we move ahead? Shall we move ahead, guys? Everybody. Wait a minute. Okay. Let's talk about this. That is molar conductivity. Current of all ions when 1 mole of electrolyte dissolved in V milliliter of solution. So let's talk about this, right? So now, molar conductivity. Now, guys, tell me one thing, right? Let's make 3 tools here, right? 3 beakers here. This is the first beaker that you have. This is the first beaker that you have. Then one more beaker we need. Okay. One more beaker we need. Then one more beaker we need. Okay. Let's understand what is molar conductivity. What was conductance? Conductance was in this overall volume. What is the, in this overall volume, what is the conductance? Right? That is defining the conductance. The conductance in full beaker, right? That is called the conductance. The conductance in this particular volume. Now we are specifying that we have 1 milliliter. Here, volume is going to be 1 milliliter. Molar conductivity, we are not specifying the volume. This is volume is not specified. Volume is not specified, but moles are. But moles are. See, you can understand this that, for example, I fix that in my class, let's say there should only be 20 students, there should only be 30 students. So that means I am specifying the number of students. If I say I'll teach only in one big hall, I'll teach only in this much size of the room, right? So that is I am specifying the volume of the room, right? So here they are not specifying the volume, right? That I'll teach all the students that I can cover up in one room, I'll teach these many students. They are not saying this. They are saying that I'll teach 1 mole of students. That means the conductance of 1 mole of electrolyte. Here we are saying that 1 mole of electrolyte, the conductance that it is carrying. Now that 1 mole can be in 1 milliliter, it can be in 2 milliliter, it can be in 3, it can be 4, it can be 5, it can be 6, doesn't matter. Volume can be anything, right? But moles has to be 1 only, right? Moles has to be 1 only. That is molar conductivity. Okay? So, let's talk about this thing, what is molar conductivity and what is the formula, right? Yes, let me just write down the formula of molar conductivity here, right? So, if I erase this here, right, then we can write the formula of molar conductivity. Molar conductivity is defined as, this is kappa into 1000 divided by molarity, right? Now this kappa is nothing but this will be, see, kappa should be in Simon per centimeter. Then only you will multiply it by 1000. If kappa is in meters, let's say the kappa is in meters, then the answer is going to be molarity into 1000 if kappa is in Simon per meter. This you should remember, right? It's a very, very important point. When usually you will see it in centimeter only, but what if they confuse you by giving you in per meter, right? Then you will apply this particular formula, not that formula, right? That you should be clear on. Now this kappa is this kappa is conductivity, this is molar conductivity, this is molarity. Okay. So now let's discuss one question based on this, that is NEET 2016. It says that molar conductivity of a 0.5 mole divide per decimeter cube, okay, solution of this much with electrolyte conductivity is this. Now it's a game of what? It's a game of units as well, right? So if you see this, this is mole per decimeter cube. Decimeter cube is nothing but liter, okay? So that means they are saying that volume in liter is nothing but, not volume in liter, molarity, we know that molarity is nothing but moles divided by volume in liter, and that is defined to be 0.5. So this they have given you molarity, right? Now they have given kappa, this is kappa. Now simple, you can just apply the formula kappa into 1000 divided by molarity. Kappa will be 5.76 multiplied by 10 raised per minus 3 into 10 raised per 3 divided by 0.5, and this is going to be the answer. It is going to be 11 point something. So answer is going to be 2B is the correct answer here, right? Okay. Yes. Now let's talk about the next thing, that is limiting molar conductivity. Now guys, anybody, can you see the definition here? When the, chalo, I'll just, yes, very good Triana, very good. Now let's see limiting molar conductivity. See, limiting molar conductivity means now you are keeping this particular solution at infinite dilution, right? So at infinite dilution, what is the molar conductivity? Infinite dilution. What you are keeping as the molar conductivity, that is defined as limiting molar conductivity. When dilution is infinite and concentration is inverse of dilution. So if dilution is infinite, you are adding water to next level, then concentration is approximately equals to 0. That is called limiting molar conductivity. So you can say when concentration approaches to 0, dilution approaches to infinity, that molar conductivity is called limiting molar conductivity. What are these two signs? This is at concentration C. This is at concentration 0. Okay, these are the molar conductivity. Now, what is equivalent conductivity? If you remember, we have already studied molarity, normality, right? Now, if you talk about molarity, normality, a very simple game is that molarity is equals to number of moles of solute divided by volume, and normality is equals to number of gram equivalents divided by volume, right? That is the difference. The same difference is between these two things, that molar conductivity is, we are talking about 1 mole, right? So that is kappa into 1000 divided by molarity. But equivalent conductivities, we are talking about 1 gram equivalent. In 1 gram equivalent. So that's why molarity will be replaced by normality. Everything else is going to be same. Okay? Everything else is going to be same. Instead of molarity, you will have normality. Now, what if they give you what is normality, what is molarity? You can easily convert normality and molarity here. Right, everybody? Okay. Hmm. Hmm. Sai is asking me something, right? Definitely, guys, definitely. That also, to us also, it's very disappointing when we see the students who are more interested in not the teachers, not the content, but I don't know what they are more interested in. They are just interested in which teacher is a star teacher, which teacher is more famous. I think teaching game is now not more of teaching. It's more of the teacher who is getting more views, right? We will see that the teacher how they are teaching doesn't matter to them, right? Is the teacher giving them full attention or not doesn't matter to them, right? So the mindset of today's generation, what I can do is I can feel pity about them that they are getting everything for free, right? And that's why so many teachers they are taking for granted. And I wish that at my time also we had so much free education, but we were not so lucky. But today, if I see that the education is totally free of cost, everyone is providing you best content, right? Then definitely, if something is provided in totally free of cost, right, the value obviously decreases. And this is, I think, what is happening with teachers as well. It's a sad reality, but this is the reality. What to do, right? I think the downfall of teachers are here, right? Because we know that it's like, see, it's the same thing, right? Have you ever seen Masan movie? Have you ever seen really good Oscar level movies? Right? No, right? We don't see that, right? We only care about, okay, this is Shah Rukh Khan, this is Salman Khan movie, this is Amir Khan's movie, right? So we only care about those things. Okay, some big hero is doing this movie, that must be great, right? If some small hero, heroine is doing their best in some movie, we don't care about it, right? Similar thing is happening to teaching world, right? We don't care what is the content, how much efforts are being, the teacher is putting, doesn't matter. All what matters is the popularity is low, right? Oh, ma'am is not like, too many students don't know ma'am, right? So, Esther, what to do? I'll not like learn from ma'am. I'll learn from some teacher who has good followers, right? So it's very sad that teaching is now related to the amount of followers that you have, right? I don't know where we are going, but we are going somewhere where we should not go, where the teaching and education world should not go. What to do, right? All I can do is I can teach you, right? In my hand, I have just one thing, that is I can teach you with all dedication, right? Without looking at if you're interested or not. I know that maybe this is there in the recorded version as well. Maybe some student out there, right, that is in need, right, of content. They don't know Hindi, they don't have good content in their regional language. Now they are looking for something in English, right? Now for them, I think we are here, right? You watch it on recorded version. Even if one student I'm able to change their life, right? I'm able to teach them the concept that they are finding difficult, right? Even if one student who is sitting in the exam hall or they're thinking that yes, this whole chemistry ma'am has already taught me. I feel lucky. I feel blessed. And I know that those blessings will go somewhere, right? And because of those blessings only, I think I'm standing here, right? So that's all what I have to say, right? Sure. So that is the harsh reality, but we can't do. I started questioning myself. There was a time, just one, because I have never seen very low students. I have never seen. There was classes when I used to teach 500 students in the live class, right? So I have never seen such less students in the classes. So I used to feel that what has happened? Is my content good? I started questioning myself, right? You self doubt yourself. Then I saw that yes, I'm providing the best that I can, right? I know that whatever I'm teaching them will be there in the exam. Nothing beyond that will be there in the exam. I know that. And I was like, why am I sad? It's my duty. I can do only this much. Then I analyze this thing, that what exactly is the situation, right? Then I got to this conclusion that exactly this thing is happening. You know, Trust me on that. If someday one of my reel or one of my Instagram reels or my YouTube shorts gets viral, you will see thousands of students in the chat box. The content will be same. The way I'm teaching will be same. But students would die to talk to me. Why? Because now ma'am is popular, so let's talk to ma'am. Now ma'am is not popular, so we don't care. So it's more of like we are heroines, right? We are not, guys. You need to see a teacher as a teacher, right? Don't see how many followers a teacher is having. Nothing is going to happen with teachers' followers. They will have 500K followers, doesn't matter. Are they teaching you? Are they there? Are they completing the syllabus? That's what matters, right? Still you have time. Still start like watching the content that is for you, right? These followers, these are not going to do anything for you, right? So let's talk about this. The resistance of one normality or solution of acetic acid is this. Resistance is given to you, right? Normality is given to you. When measured in a cell having cell constant, this G star is given to you. The equivalent conductance of this. See, we'll use two things here, okay? We know that we'll use two things. Firstly, we know that to calculate the equivalent conductivity, what we need is kappa into 1000 divided by normality. This is what we need. Normality, we know that, but we have no idea about kappa. So for that, we'll take this thing. We know that G into G star is equals to kappa. Okay. Now, resistance is R, so this will be G star. Resistance is opposite of conductance, so this will be G star by R, and this is going to be kappa. Now, kappa is nothing but that is G star by resistance. So, can I just write it here? Kappa is equals to G star by resistance. Now, what is this G star, guys? Can you see that? Now, you have to also take care of the units. This G star is per centimeter. This is going to be ohm. So, can I just write it as this is 1.15, and what is the resistance? That is given to be 250, right? I know that this is this was in per centimeter and this was in ohm, so it will become per ohm. So the answer is going to be Simon centimeter. That's why I need to apply this formula. I need to multiply 1000 over here, not here, right? Okay. Time will change, ma'am. You will follow. Okay. Thank you, Sai. The difficult is the live classes timing, ma'am. Following your recorded session, you are a really good teacher. Thank you so much, Sai. Right? Okay. Who is this Bhuvana? Bhuvana. Beta, इतनी अकल कब से आ गई, huh? What do you think, huh? Teacher is teaching in English, they don't know Hindi, we can say anything about them. Like, how can, you can, you know what, after the class, when I like get time, I try to do something productive, not to come to someone's live and chit chat, not even chit chat, bully them. Who is paying you, beta? Who is paying you for all of this, right? So this is kappa. Kappa is going to be this. So it is going to be 1.15 divided by 250 multiplied by 1000. Normality is 1, and that is going to be the answer for equivalent conductivity. And you can see the answer will be 4.6. After doing the multiplication and division, you can do it directly here. 0, 0, it will cancel. This is 4, so multiplied with 4. So answer will be 4 point something. So that is 4.6. So answer is going to be B is the correct answer here, right? Okay. In a NEET, not too high calculations they ask you. Okay. Now let's talk about this. That is the relation. Okay, the relation between molar conductivity and equivalent conductivity, right? Students, for this, those students who have totally like skipped what was molarity normality relation with n factor, for them I am doing this. Equivalent weight is equals to molar weight divided by n factor. Okay. This is one formula. This is all the conclusions for mole concept that I am bringing here, right? So equivalent weight is equals to molar weight divided by n factor, that we know. Now I told you that molarity is equals to number of moles by volume in liter, right? Now if you see, number of gram equivalents is nothing but it is given weight divided by, instead of weight I'll write mass. Equivalent mass is equals to molar mass by n factor. This is given weight by equivalent mass. Equivalent mass is nothing but it is molar mass multiplied by n factor. So can I say number of gram equivalents is equals to number of moles multiplied by n factor? This is the next formula that we know. Because they can interlink these two things and ask you the question. That's why I'm telling you, right? This is the next formula that we already learned. Now, third thing is how molarity is related here. We know that, guys, molarity is equals to number of moles by volume in liter, right? We know that normality is number of gram equivalents by volume in liter. What is number of gram equivalents? That is number of moles multiplied by n factor in volume in liter. And what is number of moles by volume in liter? That is nothing but molarity. So normality is equals to molarity into n factor. So can you see these three formulas we have already done? These three formulas are very, very important. That's why I told you mole concept will be useful throughout your physical chemistry, right? So 1, 2 and 3. These are the three formulas that we know. Now when we talk about this thing, what is this? Equivalent conductivity. This is also mentioned as this. This is also written as N here. Totally your choice. Equivalent conductivity is nothing but that is kappa into 1000 divided by, I'll just write it here, kappa into 1000 divided by normality. What is normality? Molarity into n factor, right? So this will be 1000. This is molarity into n factor, right? So can I say now, in fact, here I should write it here only, molarity into n factor. Now if you see this particular thing is nothing but that is molar conductivity. So that's why we write that this normal equivalent conductivity multiplied by n factor is equals to molar conductivity. So based on any of these things, they can ask you the question in the exam, right? They can confuse you with the combining these formulas with this formula that you have learned in electrochemistry, these formulas that you have already learned in the mole concept. Okay? Yes, everybody? Right? Now, let's talk about strong electrolyte and weak electrolyte. If you talk about strong electrolyte, what is that? 100% dissociation is there, right? Like if you have 100 molecules, all these 100 molecules will get dissociated here. That is for strong electrolyte, like strong acids, strong bases, salts, all these are strong electrolytes, right? Now, let's understand what is going to happen here, right? So, this is with dilution what is happening to molar conductivity. This we are talking for strong electrolyte. So, for strong electrolyte, what we observed is this is exactly directly proportional to each other. If you see this, no, then this is the limiting molar conductivity that you will have. In fact, this is like this. Even if you try to draw a graph between this, y-axis is nothing but that is molar conductivity. Y is equals to mx plus c. Okay. What is x? That is the under root of c, right? What is intercept? That is limiting molar conductivity. And what is slope here? That was a. And a is going to be negative, right? So it is going to be minus a into under root c. Or this is the Debye on Sagar equation, that is, this is the equation that you have. Okay, this is the experimentally defined equation, right? Now, what we observe that when you compare this equation with y is equals to mx plus c, this is y, this is x, this is m, and this is c. So we know that the intercept where it is touching the y-axis is limiting molar conductivity at infinite dilution, where concentration, this is the concentration, this is becoming zero. On x-axis, you have under root of c. On y-axis, you have molar conductivity. So he is saying that whenever you are diluting, you are adding water, the molar conductivity here, can you see, that is going to increase. So that means we can definitely find the limiting molar conductivity of the solution. Okay. Now, from this particular equation, can I say one thing, that on dilution, limiting molar conductivity increases. Can I say that, guys? On dilution, limiting molar conductivity increases, right? That I'll tell you the reason behind that also. Now just see that whether this conclusion is clear. As dilution is increasing, because here concentration is increasing, here dilution is increasing. Because concentration and dilution are inversely proportional. If you dilute some, if you're adding water, you are decreasing the concentration. If dilution is increasing, concentration is decreasing. Right? So as dilution is increasing, molar conductivity is going to increase, and at zero it is going to turn to limiting molar conductivity. So that we have two conclusions from this graph. One is that we can find the limiting molar conductivity. We know that intercept is, in this graph, the intercept will tell you the limiting molar conductivity. And we also know that over here on dilution, molar conductivity is going to increase. These are the two conclusions that we can draw from this particular graph. Now, if you see this graph, same graph, in case of weak electrolyte, you will find something different. That is, in case of weak electrolyte, what is happening, right? Same thing, as you dilute, as you decrease the concentration, dilution is increasing, it is increasing. So that means one thing we can say here also, that on dilution, limiting molar, the molar conductivity will increase. That we are sure about. Okay. But can you see that at one point, molar conductivity is parallel to y-axis. That's why we can't find, we are not able to find what? Limiting molar conductivity. From the graph, you won't be able to find the limiting molar conductivity here. That is the main problem, right? In strong electrolyte, you can find, in weak electrolyte, you can't find, right? Because in weak electrolyte, you can't find, that's why we will study about this law. But before going through the law, let me tell you one very important thing. Why this happens like this? Now it is increasing and it is touching here. Here it is increasing, but it is increasing to that extent that it is going parallel. That means very high increment is there, right? Let's understand this thing. So for weak and strong electrolyte both, we'll talk about on dilution what happens. On dilution, what are the things that will be changed? Okay, on dilution, what will happen? Yes, everybody. Till now, if you have any problem, then let me know in the chat box. Students, if till now you have any problem, then let me know in the chat box. Okay, let's see this. Firstly, I'll talk about conductance. Then I'll talk about conductivity. Then I'll talk about molar conductivity. Okay. Third one is molar conductivity. This is for strong electrolytes. Okay. Let's talk about this one by one. On dilution, what we are doing, we are adding water. Right. So concentration is decreasing. So see one thing, what is going to happen here. See, when we are saying that you are adding water, right? So let's say earlier you have, I'll just make a beaker here, right? Okay, so this is the beaker that we have. Now see one thing, what I'll be doing here is, this is water. Firstly, let's say this much ions you have of which one, some NaCl, some strong electrolyte you have that is 100% dissociated. All the molecules are already into ions. There is not even a single molecule. There is not even a single compound. All are ions. Let's say you have 200 molecules of NaCl. Now you have 200 Na and you have 200 Cl. All are dissociated. Now what you will do, you will start adding water. Adding water, adding water, adding water. You're diluting it. You're adding water, you're adding water, you're adding water. Now what is happening? Number of ions are constant. There is no increment in number of ions. Can I say in strong electrolyte, there is no increase in number of ions. There will never be any increase in number of ions of the solute, of the electrolyte that you are adding, right? Electrolyte will not increase the number of ions because already it's 100% dissociated. The dissociation will not increase. But now what will happen? Let's say earlier you are 14 students, right? Earlier I put you in a very small room, right? Very congested,ly you are sitting, right? Now I give you a big house, right? There is 5 rooms, 10 washrooms, 2 kitchens, right? Full on one big hall, home theater, everything is there. Now you're like super excited. What big boss house this is, ma'am, right? You're super excited for this. Why? Your conductivity will now increase. Earlier you will just in one room, right? You are sitting here looking at each other and getting irritated, right? Now you have big full-fledged house. Now what will happen? You will start moving here and there, right? Now what is going to happen? Now your conductivity will increase. Is it? Yes. Because now you have more volume, right, to move here and there. That's why conductivity will increase. So can I just write it here that more, what should I write? More area to travel. So it increases. So conductance will increase. Okay. Now let's talk about conductivity. In conductivity, it doesn't matter that you have a big house or a small house. Okay. It doesn't matter. Even if you are living in a house of 7 rooms, even if you are living in a house of 2 rooms, you will have only 1 room. Doesn't matter, right? So if I say my dilution is earlier this much, okay? Let's not draw it like this. Let's draw it like this. Okay. So let's say this is the volume that you have. Okay. So this is the volume that you have. This is 1 milliliter of volume. Earlier you had this much water, right? Now you are increasing, you are adding the water. See, number of ions are not increasing, right? Now you have this much water, this much water, and this much water, right? You're adding. But volume is not increasing. See, what was there? Earlier you had this much. So what was there? That you have, let's say, these many ions you had. Let's say you have 10 ions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say you have 15 ions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So let's say you have 20 ions here. Okay. Just an assumption. Now, what I am doing is I am increasing the water, right? So if I am increasing the water, what will start happening? Let's say I have increased the water to this much time, right? Now I have diluted the solution. Now, you know what will happen here? Now, wait a minute. Now, what will happen here is that those 20 ions, because number of ions are not increasing, those 20 ions will try to accommodate in this much: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20, right? Can you see number of ions in that unit volume has now decreased, right? So can I say that number of ions in that unit volume, right? Number of ions in unit volume has decreased. So it decreases. Okay? It's the same situation. Let's say you and your sibling. If you have a house which is having only 2 rooms, you will definitely have to stay together. Let's say you have a house which has 10 rooms, right? So you'll definitely stay away from each other, right? I'll have my own room, you have your own room. Similarly with the ions, when they have less volume, they will stay together, right? When they have more volume, here number of ions in per unit volume will decrease. Okay. Now, what about molar conductivity? What about molar conductivity? In molar conductivity, I am not talking about a specific volume. It is the same case as conductance, right? For 1 mole, number of ions are not going to change. I am specifying that I need to have 6.022 into 10 raised to power 23 ions. I have specified 1 mole of electrolyte. For 1 mole of electrolyte, right, if volume is increasing, that means area is more, now way of traveling is more, right? They can move here and there more, right? They have a garden, they have a study room, they have a bedroom, they have a drawing room, they have 2 kitchens, right? So they are more happy, right? So that's where when volume increases here, molar conductivity will increase. Okay. Now, similar situation is with weak electrolyte, guys. Similar situation is with weak electrolytes. Now, who will tell me everything is going to be same? Everything is going to be same. If I talk about conductance, obviously conductance will increase. Why? I'll tell you. Conductivity, right? And this is molar conductivity. Molar conductivity. Now, if you see this here, right, what will start happening on dilution? What you will see is on dilution, earlier, let's say it was 70%. On dilution, when you add water, now it will go to 100% dilution. That means on dilution, the dissociation increases. Dissociation increases, right? So here conductance will increase because volume has increased. That's why conductance will increase. But also number of ions increases. Here conductance is increasing because dissociation has now increased. That is the reason it is increasing. Because they can ask you assertion reasoning questions, right? That why in weak electrolyte conductance is more. It is because of number of ions dissociated are more here. Not because of volume only, right? Conductivity will decrease, right? So it increases. Wait a minute. It will start decreasing. Why conductivity decreases? Same. It is same number of ions per unit volume that decreases. What about molar conductivity? Molar conductivity also increases. What is the reason? Same number of ions increases. Right? Now, can you see one thing? Ma'am, here it was decreasing, but it is meeting a point, that is the intercept. But in this case, ma'am, it is increasing and it is going parallel. Why it is so? Because in this case, not only volume, but dissociation also increasing. Dissociation also increases. So, number of ions increases. See, in strong electrolyte, it is increasing, molar conductivity is increasing, because what you have here is, in that particular case, the volume is increasing. But in case of dilution, in case of molar conductivity of weak electrolyte, number of ions dissociated has also increased. That's why it is increasing to very exponentially, it is increasing here, right? And that's why it is getting parallel to the y-axis. Okay, right? Degree of dissociation of weak electrolyte and concentration. Yes, Triana, I'll just write about that, right? Okay, we are just going to do that, right? So that was a theoretical question. This I already told you, right? So let's talk about this thing now. That is, molar conductance of an electrolyte increases with dilution according to the equation. That is this. This is the equation that you have. Which of the following statement is true regarding this equation? This is NEET 2023 question. And they are saying that choose all correct options from here. This equation applies to strong and weak electrolyte. Is it? No. It is only applied to weak electrolyte, not to strong electrolyte. It is not applied to strong electrolyte. Volume of value of constant A depends upon the nature of solvent. Yes. Value of constant A is same for BaCl2 and MgSO4. No. Value of A is same for both BaCl2 and MgOH twice. Right? So guys, here we have to choose the correct options. And for that, the value of A, if you see, that depends upon nature of the solvent. And that is the reason, if you see, it is same for this, that is not correct. Why? Because Ba2 positive, this is having 2 Cl, this is having 1 Mg2 positive, this is having 1 SO4 2 negative. But in this case, what we have is BaCl2 and this is having MgOH twice, right? And in this case, if you see, it is going to be, wait a minute, it is going to be, I'll have to see the value here, right? Because there can be a big doubt in this particular case, right? Because don't ask you multiple choice answers, na? That's why. Wait a minute. Okay. Okay. Yes, it is same only. Yes. So wait a minute. Let me just tell you that same logic is applied there. See, here you have 2 positive. This is, if you dissociate this, this is going to be Ba2 positive and 2 Cl negative, right? And here it is going to be Mg2 positive and this is SO4 2 negative. So here it is 1:2. Here this is 1:1, right? But in this case, it is 1:2, Ba2 positive and Cl2. This is 1:2, Mg2 positive and OH twice. So that's why this value is constant here for both of them, right? Okay, the ratio is constant. That's why I think the question will be, because they don't ask you multiple answer questions. So I think the question will be firstly telling you this. They will give you A. A is all of them is correct. B is A and B statement is correct. C is A, B, C is correct. D is B and D is correct. Out of this, you have to choose. Because multiple choice answers are given in JEE. So I think that is going to be the rule here. Right? Okay. Now, last is Kohlrausch Law. And here we are going to see last particular thing that we are going to study for this particular lecture. Okay. Yes, everybody, let's study. See, if you talk about this thing here, we were not able to find out the limiting molar conductivity of the weak electrolyte. If you have seen this here, we were not able to find it, right? So to find it, we have a law that is very simple. It says that if let's say you have AB2 kind of molecule, right? Molar conductivity, we know that this is dissociated into A2 positive plus 2B negative, right? So here answer will be that this is equals to limiting molar conductivity of individual cations and anions multiplied by the stoichiometry. If it is 2, it will be multiplied by 2. Let's say you have limiting molar conductivity of A2B3. Now students, we know that A2B3 is nothing but it is dissociated to A3 positive plus B2 negative, where here you have 2 of A, here you have 3 of B. Okay, now I'll write it here that this limiting molar conductivity is equals to 2 into limiting molar conductivity of A3 positive plus 3 into limiting molar conductivity of B2 negative. And that is going to be the answer here. Okay guys, is that clear to everybody here or not? Right? What we have here is, we will say that if you want to find out the limiting molar conductivity of a weak electrolyte, that is equals to the limiting molar conductivity of the individual ions. Right? Now let's see how to actually answer this. This is the example that I have already given you. Let's see how to answer this. Which of the following expression correctly represents the equivalent conductance at infinite dilution? Right? Given that, okay, so they are saying that which of the following expression collectively represent the equivalent conductance at infinite dilution, that is equivalent conductivity of Al2SO3. See, Al2SO3 means you will have 2 of Al3 positive plus 3 of SO4 2 negative. So 2 of limiting molar conductivity of Al3 positive, so this is eliminated, this is eliminated, this is eliminated, and 3 of SO4 2 negative. So answer is going to be A, and this is a very, very old question that you had about it. Okay, so that's how, wait a minute, given this are equal, acha, they're asking you the equivalent conductivity. Yes, that's what I was thinking. Yes, equivalent conductivity. They are not asking you guys the molar conductivity. In molar conductivity, you will multiply it with number of ions. Okay, so molar conductivity of Al2SO3 thrice is going to be this. But in equivalent conductivity, right, you will not multiply it with the stoichiometry. So equivalent conductivity is going to be simple. That is just the ions, right? For equivalent conductivity, because there is n factor involved, that's why we don't multiply it with the stoichiometry, right? So that's why answer is going to be B is the correct answer. Now let's see the next question here, and this is the molar conductance of three things are given to you at infinite dilution. Okay, the molar conductance of CH3 is going to be what? See, you have CH3COOH, right? Its molar conductivity is going to be, we need to have CH3COH, so I'll firstly add CH3COH, CH3COONA. Now I need to have H positive, so for H positive I'll add HCl, right? For H positive I'll add HCl. Molar conductivity, wait a minute, yes. So here it is going to be molar conductivity of HCl. Now I'll subtract the molar conductivity of Na and Cl from here, right? Because in the end I need to have this thing and this thing. So for that, this will be eliminated, this will be eliminated, right? For that, what I'll do, I'll subtract molar conductivity of NaCl. And then you will put all the values here. Molar conductivity of NaCl is 126.5, 126.45. What is the molar conductivity of HCl? That is 426.18, 426.16, I think. What is the molar conductivity of CH3CONA? That is 91.0. So add this, do the calculations, and you will get your answer, right? Okay. Yes, everybody. Now, before going through the homework, there is one important thing that I need to tell you here, right? That students, one more question they can ask you. What is the degree of dissociation? Degree of dissociation is molar conductivity at concentration C divided by molar conductivity at infinite dilution. Now, if you talk about this, you will see from this, you will find out from this particular thing, that is kappa into 1000, okay, divided by molarity. For to find molar conductivity of concentration C, you will find it from here. For this, you will apply Kohlrausch law, whatever is the pronunciation, right? You will apply this particular law, right? This we have already seen a sample that how to find the conductivity here, right? This we have already seen the sample. Now, after this, what they can give you is, they can say that you have, they will say that find out the degree of dissociation, find the dissociation constant, right? So in these cases, the dissociation constants are going to be, because this is going to be Ka is equals to C alpha square. C is nothing but the molarity. C is nothing but the molarity. And alpha is the degree of dissociation. Degree of dissociation you will calculate from here. Molarity into alpha square, you will have your answer, right? Or sometimes it is also written as, to be precise, it is also written as Ka is equals to C alpha square 1 minus alpha. Okay, so you do this or this, you will get approximately the same answer only. Okay guys, so that's it for today. And yes, now this is the homework. I know that you are not going to do it, right? I have no expectation, right? So you can see this is the homework. You need to tell the units of the cell constant. You can, if you want to answer, you can tell the answer in the comment section. And this is another homework for specific conductivity of a saturated solution of AgCl is this much. If Ag is this and Cl is this, the solubility of AgCl, wait a minute, right? This, let's not do it here, because that is for ionic equilibrium. So that you will find a little bit difficult, right? We will do it in ionic equilibrium. When we study ionic equilibrium as well, then we'll do that, right? So you need to answer this particular question. Then you need to answer for Nernst equation. I gave you this question for your homework, which I saw that not even a single student has done the homework, right? So this is the answer, right, that you have to give me in the comment section. Okay, right? Okay, Trina, I have already told. So that's it for today, guys. And this is our DNA batch that you can see over here, right? Let me just show you that. This is the DNA batch, students, which is actually for 12th and dropper students. And here you will have the live classes, doubt solving, quizzes, leaderboard, mock tests, right? And the students are very disciplined and sincere there, right? There is no problem in the batch. The kind of energy that we teachers also have in the batch is next level, because students are responding, they are interactive, they answer the quiz, right? They get on the leaderboards, then they give the mock test, right? All these things are happening there, right? So if you see this here, right? Wait a minute, let me just tell you. This is, a minute. Let's say this is our DNA batch Telegram channel. Okay. So in this over here, what you will see, the test is going to be on 27th of July, and they already have their syllabus. So after every 15 days, they will have the mock test of the syllabus that we have covered within those 15 days, so that revision and there is no backlog in the batch, right? You can see for the view options here, modules are also provided to you. See, Tattva modules will be provided in all the 3 cases. In these 2 cases, it will be soft copies, that is PDF format. And here books will be delivered at your home. And it's not like one small module we will deliver at your home, right? Full-fledged, I think for chemistry part, there are 8 books in itself, right? So 11 for 11th class, you have 4 modules for chemistry. In 12th, you have 4 modules for chemistry. Someday I'll also show you what exactly are these Tattva books, why I'm focusing on Tattva books so much, right? Why they are so important, right? Then guys, you have these quick revision cards as well, as you can see it over here, right? This is just for chemistry. You will be provided with physics and bio as well, right? These small notes, these will be provided to you so that you have, like, you can do your revision, right? And this is for Prime plus NEET quick revision cards plus AITS delivered at the home, that is for 7,999. Prime Tattva NEET quick revision cards and AITS is at for 10,999. So now it's totally your choice what you want to opt for, right? And this is where QR cards will not be provided, but Tattva books will be provided in the PDF format. All the other things will definitely be there. Live classes will be there. All the other things will definitely be there. Okay? Yes? Okay then, students. Bye-bye. Take care. See you all in the next class. Bye-bye.